In this video, I'm going to discuss the gram stain. So gram stain is a way to differentiate bacteria based on the makeup of their cell wall. Gram positives are going to have a thick layer of peptidoglycan, and gram negatives are going to have a thin layer of peptidoglycan that's kind of sandwiched between an inner membrane and an outer membrane. Knowing the gram result will allow us to prescribe the appropriate antibiotic, allow us to identify the microorganisms that's causing the infection, and give us a lot of information about the pathology and overall structure of the microorganism. It's a very important diagnostic tool, and it's commonly used all over for diagnostic purposes. So I'm going to describe the steps of the gram stain. There's some materials that you'll need. So you'll need an inoculating loop, the infrared incinerator, the bacteria that you wish to gram stain, and then you'll need a series of stains: crystal violet, grams iodine, 95% ethanol or some other type of decolorizer such as acetone, safranin, distilled water, a microscope slide, and a disposal container. The first thing that we're going to do is we're going to label our slide. And I'm going to label this in the cloudy part of the glass, and I'm going to say E. coli. And now it's labeled. Then what I'm going to do is I'm going to transfer a small amount of water to the center of the slide, and that would be only if I'm going to be grabbing bacteria from a plate. But since I'm going to be grabbing bacteria from this culture tube, this broth tube, I'm not going to add any water to my slide. I'm just going to take bacteria directly from the broth tube and put it on my slide. So to start my transfer, I'm going to sterilize the loop. Then I'm going to grab my bacteria tube. I'm going to aseptically transfer some bacteria to the center of the slide. And I'm going to do this a couple times since it's coming from a broth tube. And then I'm going to flame sterilize this again. And I'm going to set my slide aside in order to dry. So now I'm going to show you how to start with a plate. So like I said before, you're going to have a microscope slide. You're going to label it. And then you're going to try to transfer a small drop of water to the surface of the slide. So now that I have my water on my slide, I'm going to flame sterilize the loop. I have my plate of bacteria ready to go, and then I'm going to obtain some bacteria from the plate. So I let my loop cool off for just a little bit. I can stab it into the very edge of the agar plate just to make sure that it's cool, and then lifting up the cover just slightly, I'm going to scrape a colony of bacteria off. Now there isn't very much bacterial growth on here, so I'm going to grab a little bit more than just a colony. But you're going to grab some bacteria and then transfer it over to the dot of water. And when you transfer it over, you want to spread this dot thinner and thinner and thinner so that it dries easier. And it should be slightly cloudy when you start mixing the bacteria in there. When you're done, you're going to flame sterilize. And then this slide needs to be set aside to dry. Okay, So now my slide is dry, and you can kind of tell that there is some cloudy stuff on the slide. I'll put it in front of the black backdrop. You can kind of see that it's now cloudy and it's completely dry. In order to stain this, we need to heat fix it. The best way to heat fix it is by turning it upside down and running it through a flame 3 times. But because we don't have a flame, I'm just going to stick it in the front of the mouth of this infrared incinerator. 1, 2, 3. And when you stick it in front of the infrared incinerator, it is going to heat fix it. And heat fixing will kill the bacterial cells, and it'll also force them to stick to the surface of the glass. So as you're doing your gram stain procedure, the bacteria are not going to fall off of the slide. I'm going to set my slide over a waste container, and then I'm going to apply my first stain, crystal violet. And you want to apply the crystal violet directly to the surface of the slide. I'll put couple drops so that it's completely covered. And you have to wait approximately 1 minute. So then after a minute, I'm going to wash this off. So tilt it down in the waste container, and using distilled water, I'm going to rinse it. You can kind of see that the slide is taking on a purple color. Crystal violet is our primary stain. This is the stain that we apply first. To allow the primary stain to stick a little bit more into the bacteria, we add a mordant. Graham's iodine is our mordant. So this is going to allow that crystal violet to form a tighter complex between the cell surface, all of the components inside of the cell surface. So I'm going to obtain some crystal violet, or some Graham's iodine. And I will put the iodine all over the surface of the slide. And this iodine is going to sit for another minute. After that minute, I'm going to rinse this down into the waste. And then this is the tricky part. So the tricky part comes with the decolorizer. I want to decolorizer enough in order to wash the slide clear, but I don't want to decolorize too much because then that will ruin the results. So I have my decolorizer, and I'm just going to go drop, 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 and keep dropping until it runs clear. And now it looks pretty clear. And then immediately rinse it off. You don't want to let the decolorizer sit on there for too long. And then I'm going to add the safranin. Safranin is our counter stain. Add that to the surface and let that sit for 1 minute. After about a minute or so, I'm going to rinse this off, and then I'm going to pat it dry, and then I'll look at the slide under the microscope without a cover slip, so just directly under the microscope after it's been pat dry. What happens during the Gram stain is Gram positives have that thick layer of peptidoglycan. So when I put crystal violet on Gram positives, it's going to completely absorb into that thick layer of peptidoglycan. Gram negatives have a thin layer of peptidoglycan surrounded by an inner membrane and an outer membrane. The crystal violet will adhere to the peptidoglycan, but it's going to be in that center layer, and it's very thin. When I put the iodine on them, the iodine is going to allow that crystal violet to form a stronger complex with that peptidoglycan. When I wash it away with the decolorizer, Gram positives are going to have that thick layer of peptidoglycan, so it's really difficult to wash away all of the crystal violet. So about half of the crystal violet will be washed away, but the other half will stay. So gram positives are going to stay purple at this point. With gram negatives, when I add the decolorizer, it's going to completely wash everything clear. So gram negatives are going to turn clear with the decolorizer. When I go into the final step and add the counter stain, the safranin, safranin is a reddish pink color. When I add this red pink color to a gram positive, which is purple at this point, it's not going to change the color. It's going to make it a prettier color purple. When I add this to gram negatives, which if you recall, gram negatives are now clear, this is going to turn gram negatives pink in color. So gram positives are going to remain purple after the staining procedure. Gram negatives are going to turn pink after the staining procedure.